Good afternoon, viewers. Welcome back to Easy Mathematics. We thank God today is another wonderful day. Last week we started with bearing and vectors. We were able to explain more on 4 questions on bearing. Today we want to look at vectors. Now when we say vector, a vector is a quantity that shows direction and magnitude, or it has a direction and a magnitude. And also, we have to know that what makes a quantity to be a vector is when you have something like A, B in this direction. So it is vertical in order, where the first value there is the x component, and this is the y component. So these are the components of a vector, or this shows that a quantity is in the form of a vector. So if I have something like AB with an arrow on top telling me that this is a vector AB from A to B, which is equal to 2, 3. So the component of this vector AB, is 2 and 3. And it is written vertically as it is here. But if I write it horizontally, it is a point. So this is a vector. And this is the x, this is the y. And these are the components of the vector AB. So that's the introduction for vectors. Now let's look at the calculations involved when it comes to vectors. Let's start with the inverse of a vector. Now when we say inverse of a vector, it simply means that we are moving from a point to another point. So you have a first question which says that if the vector PQ, that means we are moving from P to Q, is -4, -3, -4. Find the vector QP. When it comes to inverse of a vector, diagrammatically, or in terms of diagram, we can say PQ, so which means there's a point here P, there's a point here Q. So we are moving from P to Q. And here you have to find Q, then P. That means this time we are moving rather from Q to P, which is the inverse of this. So if I move P to Q, is this vector. But if I move from Q to P, I am trying to find the inverse, or move the inverse of that vector. And to calculate the inverse of any vector, you are going to multiply the given vector by -1 to get the inverse. So this is the vector I am to simplify or to solve for. So the vector PQ is given as -3, -4. And I am to calculate vector QP. And to calculate vector PQP, multiply this vector, which is PQ, by -1 or by negative. And what is the component of vector PQ? The components are -3, -4. So the vector QP, which I'm to calculate, I'm going to multiply it by the component of vector PQ, which is -3, -4. So the negative of this vector gives me its inverse. So we call it negative vector or inverse vector. So here multiply the negative by the negative, or the value here. So negative times -3 gives us positive, because negative times negative is positive. So I'm going to get negative times -3, I'm going to get 3. And negative times -4, I am going to get 4. So therefore, the vector QP, which I'm to calculate for, is 3, 4. And this becomes the inverse of this given vector. Always when you have to find the inverse of a certain or a given vector, multiply that vector by -1. So I have number 2. Given that the vector AB, so this time we are from A going to B, is -3, 5. Find vector BA. So you notice that they've just turned the letters upside down. So AB, now to find BA, that should tell you that you have to calculate the inverse. And to solve for the vector that has been given, which is the BA, we are going to multiply the given vector, which is AB, by -1. So multiply the vector AB by -1. What is the component of vector AB? It is -3, 5. So I'm going to say the vector BA is equal to -1 multiplying the component of vector BA, which is -3, 5. So this is equal to -1 times -3. Negative times negative gives you positive, so this will be 3. Then you have -1 times 5. The sign in front of the 5 here is positive. So negative times positive is negative. That gives you -5. So therefore, the vector AB, BA, is equal to 3, -5. And this is the inverse of AB. And what will let you know that you have to calculate for AB is you will notice that the letters that has been given as vectors has been turned upside down. So this one comes after that, and we say this is the inverse of a vector. So anytime you want to find the inverse of a vector, just multiply the given vector by -1 or by negative to get the inverse of that vector. Let's move on to the next one. We have magnitude, which is the same as the length, which is the same as the modulus of a vector. So when we hear magnitude, when we hear length, we hear modulus, they are the same. So how can we find the magnitude? Because we were told that a vector is a quantity that is having both magnitude and direction. That is either it is to the northeast, the northwest, the north south, or wherever it is. That is the direction. But with the magnitude, it's the same as the length of the vector. So how can we calculate the length of a vector? Now let's say we have a vector AB, which is equal to x, y. Let's say this, or let's use AB as the component of the vector. So we have a vector which is equal to AB. Now to calculate for the magnitude of the vector, it is the same as the vector AB in 2 bars. So this thing represents or shows that this is magnitude. If you see a vector in 2 bars, or it is between 2 bars, we say it is the magnitude. So to calculate the magnitude of any vector, we say that square root of the x component of the vector squared plus the y component of the vector also squared. So this x component represents the first value here, because when we started, we were told that in vectors, the first value represents the x component, and the second value represents the y component, and it is vertically written. So, if I want to find the length, the magnitude, or the modulus of a vector, I am going to square root and square the x component of the vector plus the y component of the vector. So from this, the a here is the x value, and the b here is the y value. So the magnitude AB is equal to the square root of, what is ax here? A. So a squared plus y squared. What is y here? B. So b squared. Then you find the value of a squared, that of b squared, put them together, you strike by the square root sign to get the answer. So let's take the first one for example. It says if the vector CD is equal to 4, -3. The vector CD is equal to 4, -3. Calculate magnitude of vector CD. Now, since we've been able to indicate that the vector is in 2 bars, it means calculate for the magnitude. So how can I calculate the magnitude? I know that the magnitude of a vector is calculated as the square root of the x component squared plus the y component squared. So I am finding the magnitude of vector CD, and this is vector CD, and it is having the component as 4, -3. So ask yourself, what is the x component in this vector, and what is also the y component? The x component is 4, and the y component is -3. So just substitute in the values. So I have the magnitude of vector CD is equal to the square root of x squared. What is the x? 4. So 4 into bracket squared. Plus y squared. What is the y? -3 is the y. So -3 squared. If you are able to substitute the x and the y component, then you simplify. So here I have the square root of 4 squared, means 4 times 4, which is 16, plus -3 squared also means -3 times -3. Negative times negative gives you positive. 3 times 3 is 9. So it means -3 squared produces or gives 9. Still, in a square root, we are going to add 16 plus 9. And 16 plus 9 is going to give us the square root of 25. Then you ask yourself, what is the square root of 25? Or, which number, what number, if it multiplies itself, it is going to give you 25. So we are going to say, since 5 times 5 is 25, then the square root of 5 is equal to 5. And you have been asked to find the magnitude of the length. So we are going to indicate our answer by saying, therefore, the magnitude of vector CD is equal to 5 units. Because the square root of 25 is 5, it means the magnitude for this vector is 5 units. We conclude our answer with the units to show that this is the magnitude of the vector. Let's take the second question. It says, given that vector AB is equal to 5, 12, find the magnitude, the length, the modulus of vector AB. I know very well that vector AB is calculated as the square root of x component squared plus y component squared. Now, look, what am I finding its magnitude? I'm finding AB. They said I should find the magnitude of AB. And what is the component of the vector AB? The component is 5, 12. This is AB. So, indicate the x component and the y. So, the 5 here is the x, the 12 here is the y. So, substitute the 5 in place of x. So, this is equal to square root of x squared. What is x? 5. So, 5 squared. Plus y squared. What is y? 12 squared. Then from here you ask yourself, what is the square of 5? Meaning 5 times 5. So I'm going to get the square root of 5 times 5 as 25. Plus the square root of 12, giving you 144. Then you ask, if I put 25 and 144 together, what am I going to get? This is going to give you the square root of 169. Then what is the square root of 169? So you notice that 12 times 12 is 144. then 13 times 13 is 169, which means the square root of 169 is equal to 13. So if we've been able to get 13 as our answer, then it means the magnitude, the length, or the modulus of vector AB is equal to 13. Then you just include your unit. And this becomes the magnitude, or the length, or the modulus of the vector AB. And that's how we calculate for the magnitude of a length, or the length of a vector. Let's look at the last question below the magnitude. We have a question which says, if the vector PQ is equal to -5, -12, the vector PQ, that is from P to Q, is -5, -12. Calculate the magnitude, looking at the bars. Calculate the magnitude of QP. Look at the point carefully. You have to calculate the magnitude of QP. And I know very well that to calculate for the magnitude of QP, the magnitude of vector QP is equal to the square root of x component squared plus y component squared. But look at what you have to find the magnitude. You have to find the magnitude of QP. Do we have QP from the question? No. Here we have PQ, but we have to calculate QP, which means we have to first solve for the inverse of this vector. And the inverse is what we started with. That to solve for the inverse, multiply the given vector by -1. So, I have to first calculate or solve for the component of vector QP, which is the same as negative the given vector. So, from here, I can say vector QP, I have to first find QP, is equal to negative PQ. What is PQ? -5, -12. Then, negative multiplies negative, giving you positive. Also giving you positive. So I can say vector QP is equal to 512. So this becomes PQ. Now I can now find the magnitude of QP because the question is asking for the magnitude of QP. So now look at something. From here, we are going to say, since the magnitude is the square root of x component squared plus y component squared, this is the x, this is the y, so we are going to say the magnitude is equal to the square root of x squared. What is the x? 5 squared plus 12 squared. And solving will give you 169, which is 13 units. Which is 13 units. So the magnitude of QP is equal to 13 units. How? 5 squared is 25. 12 squared is 14. 25 plus 144, 25 plus 144 gives you 169. Giving you 100 and giving you 13 units as your magnitude. Now note that the inverse of a vector are the same in terms of magnitude. So the magnitude of QP is the same magnitude of QP. And since we have to find QP, but we've given PQ, we find the inverse of PQ to calculate the magnitude of QP. And that is how we solve or calculate the magnitude of a vector, the length or the modulus of a vector. Let's look at the final part, which is addition and subtraction of vectors. As the name goes, we are just adding and we are just subtracting. So let's say we have a vector A as x1, y1, and a vector B as x2, y2. If I am to find or calculate the vector A plus B, first note or locate the vector you are to add. We are adding vector A to B. So what is the component of vector A? We have x1, y1 plus B, x2, y2. So we just add the x component and also add the y component. So x1 plus x1 produces x1 plus x2. And y1 plus y2 also produces y1 plus y2. And the same thing we do for subtraction, but that one we are subtracting. So when it comes to the addition of vectors, we add the x component and add the y component, giving us a resultant vector, which we'll talk about that one, God willing, the next time we meet. So we have the first example here. Given that r is equal to 3, 4, so this is the component of vector r, and s is equal to 1, 2, also the component of vector s, and we have to find r plus s. We have to calculate the vector r plus the vector s. First, locate the components of each vector. What is the component of r? 3, 4. So we have here 3, 4. Then plus the s component. What is the s component? 1, 2. Now when you look at this component, 3 is the x. Y is the 4. Also, 1 is the x and 2 is the y. So add the x, which is which we did here, x plus x, giving us x1 plus x2. So x plus this x. So now 3 plus 1, giving us 4. And 4 plus 2, giving us 6. So the answer for r plus s is the vector 4, 6. And that is how we add or simplify vectors. Then the we have to calculate s minus r. What is the vector of s? 1, 2. The same question. What is the vector of r? 3, 4. So just substitute and you simplify. S is 1, 2. So I have the vector 1, 2. Minus r. What is r? The components are 3, 4. So this is the x component. This is the x component. So 1 minus 3. 1 minus 3, giving you negative 2. Then 2 minus 4, giving you negative 2. So the answer for the vector s minus r is negative 2, negative 4. Now note that this is a vector, so you don't do negative 2 over negative 2. Immediately you do that, then you are leading to a different topic, which is fraction. So with the vectors, we don't use the division sign because it is a vector. And that is how we do addition and subtraction of vectors. Now the same thing we have here. I am coming to solve the I, and I will throw the I as a challenge for us to solve and produce our answers at the comment section, or I'll give you a number to send me your answers, where we'll show it, God willing, next week, the winner of this question. So let's look at the I. We have to solve for A plus B minus C. A plus B minus C. So let's take it bit by bit. But first, substitute the component. So what is the A? It says if A is equal to the vector 2, 7, B is equal to 1 minus 2 or 1 negative 2, and C is negative 3, negative 5. So substitute. A, what is the component? 2, 7. Plus B, what is B? 1, negative 2. Minus C, what is C? Negative 3, negative 5. You can choose to take all the three as a whole or break them down by using brackets of division, multiplication, addition before subtraction. So if I want to do the addition first, then it means I am going to tackle A plus B, which is this one. And 2 plus 1, just as we started, gives us 3. Then 2 plus negative 2. When negative meets positive, it changes to negative, because when they multiply, it produces negative. So this becomes 7 minus 2, which is 5. So adding or finding A plus B, I have 3, 5. Then I'll bring the next one, minus negative 3, negative 5. Then you ask yourself, the x component, the x component. 3 minus negative 5. Negative, negative. When it meets, it changes to positive. So 3 plus 5, 3 plus 3 gives us 6. Then also negative, negative also gives positive. 5 plus 5 also gives 10. So this becomes the answer for this. Or you can choose to take all straightforward. 2 plus 1, 3 plus this, giving you 6. Then you also take them below the y component. So let's solve the II and send our answer to this WhatsApp number 025-703-8171. Let's solve this one, send our answer to this. If God permits, when we meet again, we'll mention the winner for the B or the one who had it correct. Let's try our hands on this. So this is how we do the addition and subtraction of vectors. Thank you for staying tuned. God bless you. When we meet again, we'll look at resultant vectors, equality of vectors, and others under vectors. Don't forget to hit the subscription button. God bless you. Stay tuned for next video. God bless you. Bye-bye.